we are writing polynomial functions from a graph. So if it crosses the graph, we would look at the x-intercept, and and that would just be a single factor. If it bounces on the graph, then that means it's a double factor, and that's what we have here. We have a double factor at 1, and we have a double factor at -2, right? So what does that mean? It's basically the opposite of these numbers. So it would be x plus 2 and squared, double it, and then x minus 1 and squared. Now, the thing that we need is there could be some sort of constant that makes this graph like steeper or not as steep. So we would call that constant an a constant, and all of this is going to be equal to y. Okay, so now our goal is we need to find out what a is. To find out what a is, the easiest thing is if they give us a y-intercept. Yay, and that's exactly what they did. That's the point right here. That's the point, x is 0, y is 12. Now, we could use any of the other points except for these two, because those zero out everything in here. Remember, those are the zeros, or roots, or solutions, or x-intercepts. So we would have to find another point that we knew was on it, but they gave us the easy one. All right, so that's our x value, that's our y value, our input and our output that's related here. So we'll plug those in here, and then we'll be able to find out what a is, and then we'll fill in the general form. So y is 12, a is what we're looking for, x is 0, x is 0, and simplify. That's going to be 2 squared. That times -1 squared. -1 times -1 is 1. All right, so times 4 times 1. To get a by itself, divide by 4, divide by 4. I get a equals 3. Then we plug that 3 in for that a, and we'll have y equals 3, x plus 2 quantity squared, it's an x minus 1 quantity squared, and there's our final answer. Y equals f of x equals, that's fine. So a is 3, parenthesis, x plus 2, quantity squared. Times x minus 1, quantity squared. It shouldn't make me say that's multiply, but we'll see. Got it. So the intercepts, like we said, it's basically the opposite of whatever number it touches. It's a doubling because it bounces. Turning point, they call it. And there's the a that we're looking for. Plug in a number. The y-intercept is going to be the nice one. And there's our final answer. Check out the next one, see if it's any different. All right. Let's go ahead and do this one. All right, so where's our x-intercepts at? We got an x-intercept here at 5. I always like marking it. Made some mistakes by not marking it in the past. So it's going to be the opposite of whatever these numbers are. So that's going to be an x plus 1. And it goes through it, so there's no squared here. That's going to be an x minus 5. Because it goes through here. If it bounces, it would be squared. We need a constant a that would consider how steep or not steep it is, and it's y. They're being real nice by giving us the x-intercept, but we can find if we find any other point other than these intercepts, the x-intercepts, we can also use that. But definitely this is the easy one. X is 0, y is 10. Nice. I always like marking it, preventing my mistakes. So plugging things in, I get 10 equals A is what we're looking for. X is 0. X is 0. And a lot of times, as you do more of these, I don't mind if you streamline, you skip a little bit, but I'll be showing my work. What keeps A from being by itself? The 1 doesn't affect it. The -5 does. It's multiplying. The opposite of multiply by -5 is to divide by -5. And I do that to both sides. A is -5 goes into 10, -2 times. So now we know that A is -2. Final answer, Y equals -2, X plus 1, X minus 5. -2. Let's see. X plus 1, X plus minus 5. Yep. Just crosses it. And there we go. Everything's done exactly the same way. Remember, multiplication is commutative. Commute doesn't matter what order we do these in. Number usually goes out in front. This is the bouncing idea. It would bounce here, bounce here. So be careful. That's a 150 right there, but it's done exactly the same way.